Okay, next thing we're going to go over is something called the common logarithm. Okay, common logarithm. Okay, the common logarithm. Basically, what the common logarithm means is that if there is no base, okay, if no base is written, if no base is written, it is always what? Base what?
10.
Base 10, exactly. Okay, the people that were here on Tuesday know that because you guys got a little leg up. Okay, so if no base is written, it is always base 10. By the way, your calculators only work in what's called base 10. Okay, so essentially whenever we're doing these, your calculator could tell you 10 to whatever equals any number. Okay, so it could equal 10 to the x equals 30. You can get that on a calculator. However, calculators do not function in any other base. Okay, so if you have base 2, your calculator cannot help you. Okay, so what's going to end up happening is a lot of times in this unit, we're going to get answers that don't look like answers. Okay, they're still going to be written in logs. So you're not going to get like a definite, like x is 3 or x is -4. Okay, you're not going to get answers that a lot of people, you're not going to like it. It's going to be okay. It's fine. You don't have to get like perfect, nice, whole number answers. Okay, so just be aware that a lot of times you're not going to get, things are not going to be as pretty when we deal with logs. Okay, for number 7, I want you to simplify log of 1,000. Simplify log 1,000. Now, for this one, I already told you, if it's missing, we put in a base 10. Okay, we're also going to put in our x equals. So, x is the exponent on 10. That makes 1,000. 10 to what power equals 1,000? 10 to the third. Okay, if you have trouble remembering what power those are, what you can do is you put a decimal right after 1 and then move over the zeros. Okay, so you'd move over 1, 2, 3 zeros to get the end. If you think of the number line, okay, if you're moving to the right, it's positive. If you move to the left, it's negative. Okay, because negative numbers are on the left, positive numbers are on the right. So here, since I moved to the right, it's 10 to the positive 3. Okay, if you have trouble with that. Drop your bases, x is 3, and that's it. Now, that one's not too bad, but I want you to try this one. For number 8, again, simplify log of 0.001. Log of 0.001. Same concept. Put in your base 10. Put in your x equals. Then think about it. X is the exponent on 10. That makes 0.001. Now, same thing here. If you put a decimal point after the 1, okay, I want you to match this up. How far would you have to move over to get that decimal place there? Over 1, 2, 3 places. And which way are you moving? To the left or the right? Nope. If I go from after the 1, you move to the left, right? So that is 10 to the negative 3. So if you move 3 spaces and it's to the left, remember, negatives are to the left. So 10 to the negative third power. Again, drop the bases. X is negative 3. Okay, if that helps you, that's great. Or you can just remember that big numbers have positive exponents. Okay, so 10 to the positive exponents. Tiny, tiny numbers are going to be 10 to the negative exponent. Either way, you remember that is totally fine. Okay, 2 more and then we'll be done. For number 9, I want you to simplify log root 10. Log of root 10. Simplify log root 10. Okay, so put in your base, put in your x equals, rewrite this, 10 to the x equals root 10. 10 to what exponent equals root 10? 10 to the 1/2, right? If you need to, you can put in the power handle, so power of 1, handle of 2, if it's helpful to you. Drop your bases, x equals 1/2. And that's your answer. Okay, absolute last one, I promised. Then I'm going to give you some work time. Number 10, I want you to simplify log 10 squared. Simplify log 10 squared. Now, before I start this, I know I need to put in the x equals. I know I need to put in the base 10. Do you think I need to simplify 10 squared?
No.
No. Okay, a lot of times people see this, oh, I can do that, okay, that's 100. But look what happens, okay, if you rewrite this, 10 to the x equals 10 squared, look, the work's already done for you. You have the same base. So it's kind of like when we were multiplying things with radicals, with the roots in there. You don't actually want to multiply things together because then you're just going to take them out. Same thing here. You don't actually want to multiply things together because then you just have to get the same base again. So the bases are already done for you in these types of problems. So don't do more work than is necessary. If it was different, then yes, you'd have to do that. But I'm saying if it's already the same base, don't do extra work. It's just not necessary. Okay?